Hello everyone, today we are going to be going over lesson 1.3 in the Algebra 1 A Common Core Curriculum textbook. In this lesson, we are going to be learning to solve linear equations that have variables on both sides and identify special solutions of those linear equations, as well as use these linear equations to solve real-life problems. So to solve these equations with variables on both sides, we need to simplify one or both sides of the equation if necessary. Then we use inverse operations to collect the variable terms on one side, collect the constant terms on the other side, and then isolate the variable. So let's take a look at this example. 10 minus 4x equals negative 9x, and then they want us to check our solution. So they start by adding 4x on both sides to get the same variable on each side, and then 10 equals negative 5x is what they get, and then since they want to isolate the x, you divide both by negative 5 to get x equals negative 2, and then you plug x equals negative 2 back into the original equation, and then you can see right here on the right side that 9 minus 4x equals 9x with the negative 2 substituted in, and then that gets you 18 equals 18, which shows that x equals negative 2 is actually a solution to the problem. In this example, it's a little bit more complicated as there's more numbers, so we're going to solve 3, and then that's multiplied by 3x minus 4, but notice how it's in parentheses. And then we're going to equal that to 1/4, and then in parentheses again, 32x plus 56. So since it's in parentheses, we have to use the distributive property and get these distributed out so that you can solve the equation further. So once you do that, you get 9x minus 12 equal to 8x plus 14. And then you add 12 on each side to get 9x equals 8x plus 26. And then to get the x isolated, we're going to subtract 8x from this side and do it on this side to get 1x, which is the isolated x. And then that would be equal 26 because the 8x is gone. And then x equals 26, and they didn't ask us to check, so we don't have to check in this one. And then to identify special solutions of linear equations, they don't always have one solution. An equation that is true for all values of their variable is an identity and can have infinitely many solutions. An equation that is not true for any value of the variable has no solution. So this is basically saying that there could be more than one solutions, a million, or infinitely solutions, or no solution at all. So let's look at these examples. So in the first example, 3 parentheses 5x plus 2 equals 15x. So we have to use the distributive property once again to get 15x plus 6 equals 15x. And so we just subtract 15x from both sides to isolate the x once again. And then you get 6 equals 0, but that doesn't make sense because 6 cannot equal 0, so it's no solution. And then in the second example, we have it a little bit different. So it's still the distributive property where you multiply negative 2 times 4y and then times 1, and then equals 8y minus 2. So negative 8y minus 2 equals negative 8y minus 2, and those both equal each other, which as negative 2 equals negative 2. So, and that statement is always going to be true, so it has infinitely many solutions. So let's go over this. So here are the steps you can solve linear equations. So the first step is use the distributive property if there's parentheses to remove any grouping symbols. Then you simplify the expression on each side of the equation. Then you collect the variable terms on one side of the equation and the constant term on the other side. Then you isolate the variable and then check your solution if they ask. Or you can just check your solution every time just to ensure that you're getting it right. This is the final example. So this is actually a word problem, so sometimes we're going to need to use these in real life. So this is the example they give. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? And then so the first thing we need to do is understand the problem. We are seeing that we are given the amounts of time the boat travels and the difference in speeds for each direction. So that therefore you're asked to find the distance the boat travels upstream. Then we need to make a plan. So we use the distance formula to write the expression that represents the problem because the distance the boat travels in both directions is the same. So you can use the same expression to write the equation. The distance formula you can see right here is distance equals rate times time. So they give it to here in the example. So words distance upstream equals distance downstream. So you substitute those terms into to get this equation: x miles over 1 hour times 4 hours equals x plus 3 miles over 1 hour times 2.8 hours. And then you can see that those variables cancel out. Make sure to write the unit so you can like better understand how you can cancel out everything. So then it just like the problems we practiced earlier where 4x equals 2.8 x plus 3, and then you use a distributed property because parentheses comes first in PEMDAS. Then you subtract 2.8x on both sides to isolate the variable, and then 1.2x equals 8.4, and then once again isolate the variable. 1.2 divided by, or 8.4 divided by 1.2, and you get x equals 7. And then you can see that x equals 7 means that the boat travels 7 miles per hour upstream to determine how far the boat travels upstream. And then you multiply 7 times 4, and then you get 28 miles. So that is all of our examples. Thank you.